Computer Programming Essentials Unit 7, Part 4, last part in this particular unit. And we're going to talk about nested loops. As you can nest code blocks, you can put one code block inside another code block. You can also nest loops. And as with code blocks, a loop must be fully contained inside another loop in order to be nested. You cannot have loops that overlap. For example, if we wanted to print 3 mailing labels for each of 20 customers, we might have an outer loop for customer equals 1, customer less than or equal to 20, plus customer, sorry for the unfortunate line break there. And inside that for loop, we have another for loop for color equals 1, color less than or equal to 3, plus color, output label. So we're printing color 1, 2, 3 for each customer. So how many output labels are we going to print as a result of this code block? The way to figure that out, if you have a nested for loop, the way to figure out how many times the innermost statement will be executed is to multiply the number of times the inner loop will be run by the number of times the outer loop will be run. So in this case, customer is going to go 20 times, 1 to 20. Color is going to go 3 times, 1 to 3. So it's 20 times 3, or 60 times. We will print a total of 60 labels as a result of this code. The last of the 3 types of loops in Java, we've already talked about the while loop, we've talked about the for loop. Both of those are pre-test loops. We test the loop control condition before we ever execute the loop. The last loop that we're going to learn about is the do while loop, and it is a post-test loop. It checks the value of the loop control variable at the bottom of the loop after one repetition has occurred. And use this for when you want to perform a task at least one time. We talked earlier about the concept of priming read, and if we want to check and see if someone's entering their password correctly, we need to have some kind of priming read to have an initial value. Well, the do while loop gets rid of the need for a priming read. If we want to make sure someone's entering their password correctly, we can, inside the loop, prompt for their password, and then test their password, and if they didn't enter correctly, loop again. So we're going to keep looping while some condition is true, such as not entering password correctly. And then we'll be done when that condition turns false. So a post-test loop is a do-while loop, and it's really good for when you want the loop to execute at least once. Here's an example of what that flowchart might look like. The loop body is executed, and then the loop control condition is tested. Not sure why this nesting is here after the do-while loop. I think I screwed up. But there it is. So let's talk about making our loops more efficient. We want to avoid unnecessary operations. So we want to make our loops as efficient as possible. For example, look if we have while x is less than a plus b. For as many times as this loop executes, we're going to have to calculate a plus b. It's more efficient to declare a variable to store the result of that calculation in sum equals a plus b, and then while x is less than sum. That will be more efficient than performing that operation a plus b each time we go through the loop. Short circuit evaluation, consider the short circuit evaluation with the and the or. Remember that the and expression requires both Boolean expressions to be true, so it will short circuit if the leftmost expression is false. The or expression will short circuit if the leftmost expression is true, because the or says either one can be true for the entire expression to be true. That can help make our loops more efficient if we use short circuit evaluation and we require a compound condition. We need to be careful that we're mindful of the number of evaluations that take place, because we want to reduce the number of evaluations wherever possible. To summarize, a loop structure allows repeated execution of a block of statements. We talked about an infinite loop. It is a loop that never ends. We talked about a definite loop. That's a count-controlled loop. We talked about an indefinite loop that is controlled by some user input. And we talked about nested loops, a loop within a loop. You must change the loop control variable or the loop control condition within the looping structure. Otherwise, you will have an infinite loop. And we use a while loop to execute statements while some condition is true. It can be either definite or indefinite. Every loop has 3 parts: the initialization, the test, and the update. You can use a prefix post plus plus or a postfix plus plus. That's the increment operator, and it will increase a variable's value by 1. It is a unary operator, meaning it requires only one operand. A binary operator requires 2 operands. We looked at shortcut assignment operators, plus equals, minus equals, multiply equals, divide equals, and modulus equals. And they are the same if we have, say, plus equals loop count equals loop count plus 1, we could rewrite that as loop count plus equals 1. The for loop is a count-controlled loop. It is a definite loop. It initializes, tests, and updates all in one statement. The do-while loop is a post-test loop, and it will always loop at least once. And we need to be mindful of improving loop performance by not including unnecessary operations or statements. Here are the terms that you need to know for this particular unit. As with all of the previous units, be sure you make some flashcards. You will be expected to turn those in.